Hi, hello students. This is Ashwati Krishnan. I am here to help you with grade 10 physics. So we are going to begin our first module today, of light chapter. So today I'll be discussing about some basic concepts that you have already learned in your lower grades. So these are the topics that we will be recapping today. All these topics you have already learned in your previous grades. So first we will see the introduction to light, then properties of light, important terms related to light, reflection of light, and laws of reflection. These are the important topics that we will be dealing today. So let's begin with introduction. So as we all know that light is a form of energy that enables us to see objects around us. So we cannot imagine a world without light, right? So it is very important to have light to see objects around us. The main source of light is sun. We all know that sun is the main source of light. Now next is luminous and non-luminous objects. So as we all know that luminous means objects that produce their own light. The best example, as I discussed in the beginning, is sun, which gives out its own light. Those objects are called luminous. Non-luminous means the objects that cannot produce their own light. They can only reflect light. Like table, book, we can see table, we can see our book, we can see other people's around us. That is because the light gets reflected from them to our eyes. So we see them. These are some basic ideas. Then we are going to see some important properties. Yes. So light travels in a straight line. This we already learned, the rectilinear propagation. Rectilinear propagation of light. So this is the property which helps in the formation of shadow. So we have already learned that light always travels in a straight line. So the second important point, this is very, very important. Remember this point, as we learn this chapter. This is very important. So the speed of light in vacuum, that is 3 into 10 power 8 meter per second. And for numerical problems, we take in air as well as in vacuum the speed as 3 into 10 power 8 meter per second for calculation purpose. But in air, the speed is slightly lesser than this 3 into 10 power 8. But for calculation, we approximate it to 3. So remember this value. And the third point, light can travel through empty space, which means that it does not require a medium to propagate. We know that sound requires a medium to travel. So unlike sound, light doesn't require a medium to propagate. The best example is, the sunlight that reaches to the earth. That is one of the best examples that we can say. Then next we are going to see some important terms related to light. So the first thing is ray. So ray is nothing but it is a straight line path along which light travels. So the ray is used to show the path of light. Just remember path of light. So the ray shows the path. And how we will represent the path? Yes, a straight line with an arrow. So just draw a straight line with arrow. So this shows that light is traveling towards right. Now if you draw a straight line with the left arrow, it shows that light is traveling towards left. So this line, this ray help us to understand the path of light rays. So the ray is represented by a straight line with arrow. That's it. Now if you have more than one rays, what we will call this? More than one rays. We have group of rays. That is called, that is called a beam. A beam of light is nothing but it is a group of light rays. Very good. So we can draw like this. Okay, or we can draw like this. Okay, or we can draw like this, so meeting at one point, or from a point it is going away. Okay, this is more than one rays, it is a collection of rays. Okay, what we will call these rays are, we have three types: parallel, convergent and divergent. So the first diagram, this and this shows a parallel beam because equidistance, okay, equidistance between the rays. Now what about this and this? Just see the arrow, it is going, the light rays are going and meeting at a point, so they come close together, that is called convergent beam. Now what about this? From a point they are going out, they spread out. So if they are spreading out, it is divergent, and if they are coming closer, it is convergent. Now let's see another example. I have the rays like this, like this. What do you call this? Can I call this a ray? No. What are the conditions? Yes, a line with arrow. Now we have lines here but no arrows, so we cannot say whether it is a convergent or divergent beam. So what is required here, or what is missing here? Arrow. So if I put arrow like this, then it is a, very good, it is a convergent beam. Now if I put arrows like this, then it is divergent beam. So it is very important to mark the arrows. So keep this in mind when you draw ray diagrams. This is the important point that you should remember. Okay, there should be arrow. Only arrow can help us understand which direction the light is traveling. The next important term is reflection of light. So this also you have learned in your lower grades. Reflection of light means, yes, bouncing of light from a surface. When light hits a surface, it bounces back. That is reflection. It's a quite familiar term. So if the surface is smooth, you will get clear image. If surface is rough, you will get a scattered image, scattered reflection. Image won't be clear. Now let's see some important terms related to reflection of light. The first term is normal. Yes, as shown in the diagram, we know that it is, yes, dotted lines or imaginary lines which is perpendicular to the surface. So when you draw some dotted lines which is perpendicular means this angle is 90 degree. So all imaginary lines are shown with dotted lines. So this is the another thing that you should remember. So normal is an imaginary line which is drawn perpendicular to the surface at the point where light ray hits. So this is the point where light ray hits. So from here you have to draw the norm. Now second is incident ray. You all know that incident ray is a ray of light that strikes the surface. So in the diagram it is clear, the light ray which hits the surface. Then next is a reflected ray. Reflected ray is also quite familiar to you. The ray which bounces. Okay, as shown in the diagram. See, this is the ray which bounces. So this ray is called reflected ray. Then angle of incidence. Wow. It is denoted by angle I. Okay, it is nothing but it is the angle between incident ray and the normal. So here in the diagram you can see this dotted line indicates the normal and this solid line indicates the incident ray. So the angle between these two, normal and the incident ray, is called angle of incidence. Then angle of reflection. Now can you tell me what is angle of reflection? Yes, angle between normal and the reflected ray. So here you can see angle R. It is the angle between, yes, reflected ray and the normal. The next is laws of reflection. So this is also quite familiar to you. There are two main laws of reflection. The first one is angle of incidence is equal to angle of reflection. So here this is the angle I, this is angle R, and both angles are equal. That is the first law. Now second law is the incident ray. This is our incident ray, this is our reflected ray, and the normal at the point of incidence. They all lie in the same plane. So that's it for today. We will meet again with another module. Thank you.